Hello everyone and welcome to another Tri-C Anthropology video. It's Eric here, and today we're going to be talking about Geographic Information Systems, also known as GIS, and we're going to be using a specific one for the state of Ohio. This is related to my lesson plan on maps and map reading in Anth 2110. So we're going to be using a free version of GIS developed by the Ohio Historic Preservation Office, which is also housed within the Ohio History Connection, the State Museum, so they're kind of basically the same thing. So in order to find it, it's a little cryptic. You can't just Google search or put in the URL what you're looking for. So we're going to look up OHPO Online Mapping System, which you can see here. OHPO stands for Ohio Historic Preservation Office, and then Online Mapping System. You can use this in Internet Explorer, Firefox, or Google Chrome, which I've done here. And it's going to be the first link usually. It's going to say ohiohistory.org, or you could navigate to Ohio History. This is the helping files. You don't actually need this. This is the PDF that's going to explain a little bit of the things that we're going over in this video. So if I click on this, it's going to take me to the Ohio History Connection webpage for the online mapping system, and then I'm going to scroll down to log into existing account. So there is a subscription-based version of this, but since we're using this for class purposes and for personal use, we just want the free version. The subscription version's for professionals and contract professionals that would be dealing with, say, I need specific information about archaeological sites, historic sites, sensitive information. So that's why it's subscription-based. You have to be vetted by the state in order to access it. So we're not really concerned with that information. We just want to use the free version. We're going to use the free version, and you're going to type in the username public, and the password is password. So that's pretty simple, straightforward stuff to use, but once you're in it and you start using it, it's actually a very powerful tool to use, even the free version. So public, password, sign in. What we've got here are all of the different layers that you can turn on and off. So you can toggle all of these layers. They're turned on right now, all of them. And we're going to go through a few of them and explain how they work and how you can use them to understand and interpret spatial data. We're also going to go through how to identify coordinates within this system, and we're going to identify how to measure distances, and you could measure area. It's basically the same thing, which are some of the few tools that we can use in this GIS to gather the data for the assignment, which includes finding the soils, finding the elevation, finding distance to water, identifying other features on the landscape, and other useful things that we can do with this GIS. So we can see we've got National Register of Historic Places listed on here on this layer. So if I toggle them off, you'll notice all of these red dots are going to disappear once it loads. So there they go. And then if I turn off all the other SHPO information, State Historic Preservation Office, those disappear as well. Generally speaking, I don't need these national park boundaries listed here. So this is just showing me Wayne National Forest, Cuyahoga Valley National Park, and then the Hopewell Culture National Historic Parks down here. But if I turn them off, you'll notice a few of them disappear, and then I turn off Wayne. So I can turn them off each individually, or I can just turn off the whole layer and then not have to worry about it. And then we've got our base maps down here. Now these are always going to be here, so if I turn it off, you'll see now I'm just floating in a white space, a white void. Just looks like a bunch of relational stuff. Let's go ahead and turn off highways too, now that I notice it. Don't really need to know where highways are. It's always coming standard, turned on, toggled on I should say. The split between the Universal Transverse Mercator Zone 16 over here and Zone 17 over here, because it's really important to know which zone you're in, because you don't want to enter the wrong coordinates in the wrong zone, because somewhere in Cleveland will actually be over in, here I'm going to turn on the world imagery. So if I was looking for something in zone 17, but I typed it in with zone 16 as my zone, something in Cleveland's going to end up somewhere southeast of Chicago, which obviously is completely wrong side of the globe to be on when we're entering our coordinates. So those are just a few of the layers that we can toggle with. I'm going to zoom in to a specific location on the map here. I'm going to pick somewhere in or near Virginia Kendall Park within Cuyahoga Valley National Park. So I'm going to scroll up and turn on my National Register properties, and now you can see here's Virginia Kendall State Park. I know that in advance, but if you wanted to identify data on the map, you could simply click I want to, and then you can go to find data on the map. Now anywhere I click, it's going to tell me all of the selected layers that are on. So if I have National Register, General, and Environmental, and Base Map, it's not going to tell me what's there because the base map covers all of the surface area. So no matter where you click, you're always going to be on the base map. So it's not going to tell you what base map you're using, but it will tell you everything else. So if I click here, it's going to look at its system, and then it's going to identify results. So I only have 2 layers that are active in the area that I clicked, and that's Virginia Kendall State Park Historic District and Summit County. And you can see when I click on each one of them, it's going to highlight the area that I'm in. So it's really helpful to show me what area I'm actually in and what the heck is Summit County. So then it shows me in yellow, this is Summit County. So if I want to, let's say I don't know right away, because obviously this is for educational purposes, I knew where I was going to navigate to. But let's say I didn't know and all I had were coordinates. In that case, I'd want to go to the toolbar. Sorry, I'm so used to it, I just intuitively clicked it. You'll see a screwdriver and a wrench here. If I click on this, it's going to bring me a drop-down menu that I can do all these fun tools with. We're not going to focus on all of the tools, we're only going to focus on a few of them. And they're mostly going to be in the data and the measure section. The data section is going to tell me where certain objects are or what is in a certain area. So there's some neat things I can do if I want to, say, find everything in relation to this spot right here on the map. I could do a buffered shape search. So basically I could tell it, find for me everything that's turned on, all the turned on layers. Find for me everything within a mile of this pinpoint location, everything within 50 meters. I can set the range, and it's basically going to drop a circle around that area and tell me this is all of the stuff that's within that area. And then I could also get coordinate systems, or coordinates I should just say. So I want to know what the coordinates of this location are. So if I say get coordinates and then I click on it, you're going to see it pop it out. Eastings always come first, so because the best way to think of it is a coordinate system, X then Y. So eastings then northings, but this is basically how I got your coordinate systems for your assignment. Was I just clicked get UTM coordinates and then I took them from existing places on the map. But if, let's say I have those UTM coordinates like you guys do, I'm going to select right here, I'm going to just enter them in. You could copy and paste however you want. And then remember, like I said, make sure you're in the right zone. So if I click zone 16 north, I'm going to end up somewhere in Indiana more likely than not. So we want to make sure we're in zone 17. You can adjust the size, 1 mile, 10 miles, 25 miles, doesn't really matter. So if I close out of that and I hit go, surprise, surprise, it's the location I just chose with get UTM coordinates. So that's going to zoom you to a specific location. And what's also nice is it'll tell you if there's any active layers turned on in that specific UTM location. So right now we can see Summit County's in that UTM location, but also this National Register property. And so it's really nice in the free public version, and this is new, something that didn't always exist because I've been doing this for a few years and I've watched this GIS system evolve, is you can now, you see this little hot link here, if I click on PDF hot link, I can now download and view for free as I please the National Register nomination form for that specific property. So that's true of all of these properties. If I click on this one, sorry, I forgot I have to do find data on the map. I can do the same here. Now it's probably going to be the same National Register form because these are all associated with the same property. Or maybe those are a specific name. So this is the Camp Manitowoc Dining Hall. So we can get a lot of more historical information from that National Register nomination form just by following that PDF hot link. And again, this is just in the free version, so lots of information at your fingertips just with this free version here. Now, other things that we're going to want to know are soils. So soils obviously are super important to archaeologists. They're going to tell me something about how difficult is it going to be to dig, how disturbed might those soils be, what are our expectations for how far down before we hit sterile clay. In other words, how far down before we hit no cultural materials. Really important stuff to give you an idea or an estimation of what to expect before you go out and dig. So if we want to look at soils, I'm actually going to go to environmental data, and I can actually get other environmental data like streams, water bodies, watersheds, We don't need to worry about glacial geomorphology or physiography. That's useful stuff to know as well, but we're not going to dwell on them for right now. And you see when I turn down those water bodies, here's a stream that's been drawn in. Here's a water body that's been drawn in. So if I click Find Data on Map at Cape Manitowoc, I should have additional layers on here. So you can see I've also got my drainage map. So right away I can see this is the Cuyahoga River watershed. So it's telling me my major drainage is Lake Erie, so the Cuyahoga River drains into Lake Erie. My minor drainage is the Cuyahoga River. So everything flows into the Cuyahoga and then from there into Lake Erie. That's basically what it's telling me with this watershed. So now I got to zoom back in. And the more layers you have turned on, the longer it's going to take for the GIS to load. So let's go back to our layers here. We don't need these layers on, but we do want this layer right here called Surgo Soils. So I know it's bad, I can't remember all of the different letters and what they stand for, but it essentially stands for Soil Survey Index Units, or Soil Associations. And it's probably hard to see on this base layer, so we're going to actually, well, I'm not sure what else we would benefit from, so let's turn the base layer off. So you can see here's the dining hall, and all of these little brown lines are essentially soil associations. So if I find data on map and I click right here, it's going to tell me the soil association. So this whole area is GFD2. But what the heck does that mean? So in order to figure out what GFD2 means, we need to go to the Summit County Soil Survey. So I'm just going to type it in, and you'll see I've already clicked on this link right here, the soil surveys by state. But you can see it also gives me the PDF version of the 1974 version. Now, if I'm in a hurry, I'll just click on the 1974 version. But if you're looking for a specific county that you don't already have access to in advance, you'll navigate to the soil surveys page, and then you'll scroll down to Summit County, somewhere in here. Oh, sorry, that's the current one. I want the old one. So the current one's going to take you to a new system, the Web Soil Survey, and we're not going to get into how to work that. Because there isn't really major differences between the current version and older versions, at least in the sense of the soil descriptions. Most of the things that are changing from each iteration of the soil surveys that they publish, so if it was done in 1974, the things that are changing are areas that have been developed or have been modified in some way. So obviously if a section of West Akron was farm fields in 1974 and now it's part of a, Amazon distribution center, say, then that is going to change in the soil survey book to reflect that soil is no longer natural, it's been modified, disturbed, it's now part of a different soil category. But the categories of soils themselves are generally not going to change from decade to decade. But what is changing is areas that are natural soils, that are areas that have been developed, so on and so forth. So if I click on the manuscript here, I'm going to scroll down, and I'm going to give you a nice little tip when using soil survey manuscripts. And obviously for our assignment we're using Cuyahoga County, which is next door, but Summit County will work just as well. The way these soil associations work is they're alphabetized based on the first letter of the soil's name, and then they are A through Z. Instead of giving them G1, they just said GA, GB, GC, GD, so on and so forth. So we know that this one's kind of far down on the list for soils. Generally there's only like 4 or 5 associations per soil type. So we know that this is a soil that starts with a G. So I can immediately not have to worry about this 117 page document having to navigate the whole thing to find what GFD2 is. And in some soil association books, in the first page there's an index that tells you this symbol GFD2 stands for this soil association. But unfortunately with Summit County we don't have that. So I'm giving you the little shorthand tip just in case you're in a situation where you're looking up a soil and you don't have that index on it. So we know it starts with a G. Luckily there's only 3: Gravel Pits, Glenford series, Geberg series. I'm going to guess this is probably Glenford just because Geberg probably has 4 or 5 that would put it close to F. And GF would probably be one of the first ones in the Glenford series. So now we're going to scroll to the Glenford series. So I scrolled down to the start of the Glenford series, and what you'll find in each of these soil associations is a description of the series in general. So Glenford series soils, what are they like? Are they drained well? Are they good for crops? What's the depth of the typical soil before you hit clay? Just a general description of that soil series. And then if I want the specific soil, I'll see that they're going to be listed in bold in each one of these. So we've got GFA, GFB, GFC2, and here's our soil GFD2. In the parentheses there, we've got the same symbol that we see right here, GFD2. So that's a Glenford silt loam, 12 to 18% slopes, moderately eroded. We can learn specifically about this soil by reading this little paragraph here. So now we know something about the soils associated with the area around Camp Manitowoc Dining Hall. Let's turn that base layer back on real quick. And we can turn off the soils just to declutter some of our data on the map. The last thing that we want to do before we move over to measuring distances is looking at elevation. So you've got these base maps here of this is orthographic or satellite imagery showing you what it would look like from space. But then we also have the option to look at it from a topographic map. So a topographic map is going to give us elevation using contours. Each contour represents a change in elevation from a certain point. Now, there's supplemental information that we can gather that isn't going to be embedded in the online mapping system. Just like the soils survey, we had to go to a separate site. There's another website that I would recommend. If I type in USGS Topographic Maps, that's the base layer that we're looking at. So it says USGS Quads. That's Quadrangle Maps. Basically, it's a subdivision of the globe that they've done for these maps. So if I click on USGS Quadrangle Boundaries, and I switch over to World Imagery, and I zoom out a little bit, you'll see these faint purple lines here. These faint purple lines indicate the boundaries of each quadrangle. So that's how big a quadrangle is. It's fairly substantial, but it's also one of the standard sizes that you're going to be looking at for topographic maps because it's just small enough to encompass useful information in the map so you can get details, but just large enough that you're not overemphasizing too many details for a small area, because remember, we have to cover the entire continental United States with these maps. So if I click I want data and I click right here, it's going to tell me that this USGS quadrangle boundary is called the Peninsula Quadrangle. And if I highlight it, I can see my survey areas, or my area that I've selected is in the northeast corner of it. So if I want to look at that raw image map, so if I don't want to look at it within the online mapping system, I can navigate to this link right here, which is the National Geologic Map Database, ngmdb.usgs.gov. And if I click on this, it's going to load another version. So maps and map reading, it makes sense that we're going to be navigating to other forms of maps to gather information. So I can zoom in and just select the location I want. So I could just go like this, and this looks roughly where Virginia Kendall is, I'm pretty sure. Yep, there it is, the Manitowoc Scout Reservation. If I click here, I can see it says Peninsula, but I can also search by name. So if I type in Peninsula, Ohio, or maybe just Peninsula. There we go. So it's going to show up with the same information. Right here. And I can click on it right here to give me location so that I get the 1903 map, the 1905 map. Most USGS topographic maps were started in the turn of the 20th century, and they did them every decade or so or longer, depending on developments and needs. Obviously, a city that's growing at a really rapid rate, they need to do more USGS topo maps to accommodate those rapid changes in elevation, because they might be building a road, which might level areas. They might be building up houses, which also might change elevations and water runoff and all these other useful things that are embedded within the USGS topo map. So let's scroll down to 1994, because that's probably the version that you... Oh no, that's 1 to 1,000 scale, or 100,000. We want the 1 to 24,000 scale, which is the size of a quadrangle. And if we click on it, well, it's loading. You'll see all of this information on the margins here is not in the version that we're using in the online mapping system. So if I go back to layers, USGS quads, turn this off, and I zoom in, you'll notice there's nothing on the boundaries here because they spliced all of these maps together. Basically, it's the equivalent of if I cut out the margins and then laid them one next to the other to have one continuous map. But the margins have useful information in them, most notably the contour interval. So I won't necessarily know how many feet distance it is between each contour. And in this case, I know it's 10 feet. I can also see the magnetic declination when this map was made. I can also see the name of this quadrangle, Peninsula Quadrangle. I can also get useful information about UTMs. So each one of these line segments, if I can get over there, is going to tell me latitude, longitude, universal transverse Mercator coordinates, each one of those here. They drop off the 3 zeros at the end. And then we can also see township range system right here, range 12 west, range 11 west. So all of those useful pieces of information you aren't going to get in the online mapping system. So you're going to have to use the National Geologic Map Database to get the contour interval. So now that we know it's 10, and the general rule of thumb is it's likely going to be a 10-foot interval in a lot of places. But it's always good to check just to be safe, just in case it's 20, maybe it's 50 or 60, just depends. We could calculate it on our own if we had 2 index contour intervals and we were able to count between them. So if I wanted to count between this 900 and this 1000, is that a 10-foot interval? I'd have to use the math to figure it out. But we figured out it's 10 feet. So if I zoom in here, since we know that this is 800 feet above sea level, and yes, I know, in archaeology we use the metric system for everything else, but unfortunately the United States Geological Survey is not an archaeological organization, so they measure everything in English units. So this is the one case where we're going to be using English units to calculate our elevation, but then we're going to convert it back to meters anyway. So 800 is here, and then we count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're 890 feet above sea level, and just by using this simple index contour to figure out how high up we are. And the last thing that we'll go over, I guess I forgot the tools were out. We're going to go back to our tools, and we're going to go to measure, and we're going to select distance in the drop-down menu here. And you'll notice it presents me distance and area. So if I hover over it, it says select length unit, select area unit. I want this to be in meters. And we've got a few things on the map here that we could measure. We've got this little ephemeral stream here. There's another one over here. This one appears to me to be closer, so I'm going to click on my location, the Camp Manitowoc dining area, and then I'm going to drag it to here, and then I'm going to double click. And you'll see down here at the bottom, it says click or tap to draw a measurement line, double click or tap to finish. So if I double click here, it says 274 meters on both this line segment here and at the end of the line segment. The reason it does that is because I can measure things in basically segments. So I could click here, click once again, click once again. I want to know how far it takes, or how long it is from the dining hall to this cabin way out here. So you see each line segment, and if I zoom in further, it's going to show me them all, is giving me the distance. So this is a 30-meter line segment, this is 34. So I can see each segment of the line, and then here's my total distance at the end of the line right there. So that should tell you everything you need to know about the basics of the online mapping system. This GIS system is very similar to a lot of other municipalities. So if you're working in, say, City of Cleveland, City of Akron, Summit County, Medina County, Cuyahoga County, a lot of their GIS systems are going to be set up very similarly, where you can turn on and off your data layers. The data layers themselves are going to probably be very similar between all these free versions, and they're very useful even if you're not doing archaeology. Say you're a first-time home buyer or you're buying a new home. I know I myself did this, where I checked soil associations to see what kind of soils are there. Useful to know if you're worried about water management issues on your property. Useful to know, are there any old historic places nearby? Maybe there's a National Register property nearby. Maybe there's a historic marker nearby. Is that a benefit to your property, or does it tell you something about the history? What city are you in? What township are you in? Distance to water. All these different things that might be useful for other projects that you're working on, not just archaeology, that you can use these GIS for. So if you enjoyed this video and you enjoyed the educational content, then please donate to the Tri-C Foundation to support educational content just like this. And as always, never stop learning.